Hello! This is not a new Steve's Factory Manager version, but rather a fun little build. I'm not sure how useful it is, but I think it's quite cool. So if I step on this pressure plate, it's going to generate a random path for me over to this location over here, like so. And of course, since I called it a random, that means if I step here again, it's going to generate another path, and I can do that one more time, like that. Or even like that. There you go. So as you can see, each time it's generating different paths like that. Okay, let's take a look at how this works. Right, so quite a lot of things here. I'll go through it. What we have here is the start thing. This starts the whole thing, and then the rest here is actually doing the generation of the next block to place and so on. But yeah, so it starts here with the trigger, and then I want to load things. Let's see what that does. Well, I'm basically setting into the temp variable everything I have in the columns variable. It's called there, and I just set them all there. And it might look like a simple thing, but this is basically where the magic happens. And then when that is done, I just reset. Where's that? There we go. I reset it all, so every single block loses its collision. But since I loaded things in here, I also triggered this thing. And the reason why I triggered the quick pulsar is because, well, it's connected like that. So it does two jobs. It triggers the pulsing, and it's also resetting the whole thing. However, where is this defined? Where have I set what blocks are in the calls? Basically, what I want in calls are all those camouflage blocks. But I don't set anything here, and I don't set anything anywhere else in this whole setup. The reason is, well, if I wanted to set them all, the reason why I don't have to set it is because it's global, first of all, so I can keep values there without, it losing them. But the reason why I don't want to load it is because, well, I have a grid here of camouflage blocks. It's basically a square, which I guess we can take a look at. So instead of, when I reset, instead of removing the collision, I could just, I can remove the collision, but let's keep them at full blocks like that. And then we can clear the camo instead. There you go. So this is the grid of these clusters with the camouflage blocks in them. And, well, if I would just selected it normally, I want to loop through them, obviously. But if I did that, it would pick them one by one in a weird manner. It would take them, well, not a weird manner, but not the manner I want. It's going to pick them the closest to here. So first this one, then that one and that one, then that one and that one and that one, then that one, that one, that one and that one, and it continues like this. Which you might realize is going to be quite tricky when we want to define how to go anywhere, because if we are at this one, how do we know how to go to that one, for instance? That means that to find that one, we need to know how many items we currently have in this specific row, and that's going to cause quite some problems. So it's very tricky for us to find the next one when they are aligned like that. So what I wanted to have it would be if they are aligned like this. So we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on, and it just goes like that. But you can't really set that unless, well, you're a bit clever. So what you can do when you loop through things, we can take a look on this loop over here. When you loop through things, you can define different orders, and the cable order is nice. You just go through them in which order the cable is, basically. So the closest one first and so on. However, the standard order might be containing some magic that you didn't know it had. Basically, it's going to go through them in a standard order. And what's that? Well, which order it can find it in the variable. Okay, why is that so special? Well, what I've done in this columns one here, I prepared it so instead of adding them all here, I've added one row at a time, or one column at a time, and used cable order when I added them. So first I added all of these, right? Then when all of those were added, I just added them all at the same time. Then I added all of these guys. Then I added all of these guys. Then I added all of these guys, and so on. So if I changed and looped through cable order, it still would go like bananas like this. But since I've added them in that order and using standard order, it's going to loop through them in the order I want them to, which is this order here. Right, okay. So that's where the actual magic happens, you could say. But what we do then is we do this pulsing mechanics here, so I just flip it back and forth, the emitter, which makes sure it's triggering here. Right, then what we want to do is take the element, which would be the 2 next coming blocks. The reason why that's the case is because these are not only containing camouflage blocks, these also contain redstone emitters, which I'll come to in a second. So we pick out the 2 blocks within this cluster that we want to use. So we can actually see if we look on these guys over here. There you go. So I'm using them for both emitters and camouflage blocks. Right, okay, so then we just remove them from the temp list. There you go. And that's exactly why I have the template. If I would have removed them from the columns list, the columns variable, I would have to reset it every time. So what I do is just copy everything from the columns one when we start, and then I remove things from there instead. Right, okay. Then when we've done that, I just want to say, alright, I just got a new block, make it solid, and that's pretty straightforward. What we do is we set the full bounce here, we give it a collision, and then we set the camouflage to be a block of quartz. You can use any block there, of course, like that. So that's basically saying we found a block, just set it, and we're done with it. Now what we want to do is find out which block is our next one. And what we want to do is here we want to find how many blocks we want to skip, basically. And here we have different settings here. So here we have stored a value of 0, a value of 7, a value of 6, I think, and a value of, hang on a sec, no, 7 and 9. So basically I have 0, which means that we don't skip anything, which will mean that we move forward in this direction. So that will be the next one. If we skip 8, that means that the next one will be the one in the horizontal, the next horizontal one, because we skip 1, 2, 3, 4, 5, 6, 7, 8, which brings us back to the same one like that. If we skip 7, however, we will come to that one, and if we skip 9, we'll get to that one like that. So we basically calculate how many we should skip. And to do so, it's not super straightforward, but it should be fairly simple. What we do is we look if we're in this on this edge here. And the way we do it is that the emitter blocks inside these clusters are actually marked. I marked, for instance, the top side with a specific value, and if they have that specific value, we know it's this edge here. So I can mark them like that, and therefore, if we reach the edge over here, I know that I only want to be able to get, let's see, the 9 and the 8 and the 7, because if I have 8, I move horizontally, like that, and if I get 7, I'll actually move diagonally back there, which means that I won't move out here with any of the other 2, like so. So that's just making sure that, which is the first one here, and like I said, here we have those 2 selected, and just randomize. Actually, it should be like that. It should randomize 1, not both. That was actually a bit of an issue. This doesn't matter. Here we just have 1, which is the one if we're over here. So if we're over here, we can only move straight forward to get to the end here. So basically, if we hit this edge, we have to continue like that. And then we have this one, random most of them, which is just randomizing 3 of those like so, which is if we hit this edge. So we don't want to go backwards into that one, because then we sort of appear over there. But we can still randomize the other 3, so we can go in that direction, and in that direction just fine. And of course, if we're not at any of those edges, we can randomize between all of them like so, like that. And when we do have one of these emitters, what we want to do is make sure it persists. We don't want to ruin its value just because we use it, but we want to use it to count down, and therefore we have to decrease its value. And to do so, I'm using a trick here. You have been able to do this previously, but due to some bugs, well, basically by fixing some bugs, I allowed it to work better. So what I'm doing is telling the emitter, the steps left one, that's where we store these guys there, by telling it to increase it by 0, Right. So I'm not going to modify it, but I tell it I modify it. So previously it would detect, alright, you didn't modify it, and so on, which weren't actually meant to be there. And another thing you couldn't do was actually leave the ticks here at 0. That was also, yeah, something I didn't intend to have. It was just a extra check there, but it makes no sense actually. So what I'm doing, I'm pulsing this emitter with no difference and with no time, which basically means as soon as all these commands, the next time the emitter actually executes its pulses, it's going to revert back, which means that it's going to persist its value, well, basically reload its value the next tick, which makes sure it's not going to lose its value. So I tell it, well, I modified you, and then after 0 ticks, go back to what you used to be, which is going to be your normal value, basically. So that's making sure that it persists. And in previous versions, without these things, you could increase it by 1 and then decrease it by 1 right after to sort of keep its value, and then do a 1 tick in length here. But of course, it would take 1 extra tick for it to reset, not the next one, but the tick after that, and then it would go back. And then if you made a quick pulse, it would just break it because it went too quick. So nothing too much new, just some fixes there when you actually go with 0 values like that. Right, so now we made sure it persists, and then we want to loop through all the elements. But since we have removed elements here in the beginning, it's basically going to be the elements left, like the elements in the future, the elements we will probably go to later on. And then we check if we still have elements left by checking the steps left and making sure that that's actually well, greater than 0. And if so, we decrease it by 1, and that's why we have to make sure it persists, because otherwise we will destroy its value, and therefore you won't be able to use it anymore. And then we actually have to do this. We have to get 2 of the values and store them in an element, because when we loop through the element normally, we want to actually get both of the elements. We want to remove the emitter as well, because otherwise it's not going to use that properly. And then we just remove them from the list. So basically what we do is we pick out the next thing, the next block in line, and then when that has been done, we make sure to we make it solid, and then we randomize how many blocks we should skip, and when we've done that, we skip those blocks, so we next time can add the next block in line, because we skipped the others. And of course that results in something like this, and you can see it works just fine, even though, well, now we can see those, just because I made them visible like that, but it works the same way. And if you don't like how, like, I don't know how uneven this path is, you can actually remove these 2. So this is the one with 0 skip, and this is the one with 8 skip. So if I remove those 2 and do it again, you can see now it's going to be much smoother, but a bit more boring. So now we can basically just randomize between 0 and 8, which is either horizontally or vertically, depending on, well, which direction you look at, like that. But it still works just fine like that, and it goes all the way over there. So I'm not entirely sure what to use this for, but I thought it was quite a nice system. So there you go. That's about it. Good luck.